share some of my research in a middle development stage. My name is Joey Heinen. I'm the Digital Preservation Manager at the Los Angeles County Museum of Art, where I oversee the long-term preservation and sustainability of our time-based art and archival collections. I want to give this brief talk today as it felt like a serendipitous moment, given some work I have been doing for two incredible artists, Steina and Woody Vasulka, who have a lifelong legacy of pushing technological innovation with a commitment to open source tools and communities. So their ethos feels right at home to this group. They also have a long history with the ZKM, who have many holdings in their art collection and archive related to the Vasulkas, so thanks to the staff here for helping to support this legacy. It also just so happens that the MIT List Center is organizing a survey show of Steina's work, which opens this fall in Boston, if anyone happens to be there. And in preparation for this show, I was asked to assist in some research around the technological aspects of Steina's practice, given my decades worth of experience occasionally assisting in their archive, which mostly resides at their home and studio in Santa Fe, New Mexico. Today I wanted to present an example of an artist's archive and some recently digitized videos, how it can contribute to our understanding of the history of open source development, its successes and complications, and make a case for building stronger connections across collections to tell a more nuanced and thorough history of these key and often overlooked histories of technological innovation. As I mentioned, this research is still in development, so today I hope to share my current progress and give you a sense for what areas of this research I am looking to build upon. So first, a little background on Steina and Woody. So Steina and Woody Vasulka are often described as pioneers of video and new media art and worked collaboratively and separately from the mid-60s in New York City to Buffalo, New York, to Santa Fe, New Mexico in the 80s until Woody's passing in 2019. It would be impossible to do their prolific career justice in this short period of time allotted, but I wanted to briefly diagram some of the key through lines that led to the developing tools in the digital space in their practice and how they pushed the limits of what was possible to do with the technology of the time. Throughout their careers, there was one constant: the exploration of the signal, its immediacy, its behaviors, architecture, and its innate potential. This started with explorations via audio signals for which they would connect synthesizers such as the Buchla or the EMS VC3 and manipulate the voltage control to create unique and dynamic imagery through video systems and monitors, such as those seen in the example on the top right. This led them to realize that the signal had a life beyond its intended purposes, and they also began to play with video synthesizers such as George Brown's Programmer, where they discovered the potential of horizontal and vertical drift, as seen in their work Matrix, which expanded the bounds of the traditional film frame and showed video images moving from one monitor to another. Steina continued to incorporate sound as an integral ingredient in her practice, perhaps best seen in one of her most enduring works, Violin Power, in which she used the amplitude of the sound waves from her violin through video synthesizers to manipulate and in some cases decimate the image. Violin Power will reappear later on in her practice as a performance and immersive installation, which, as you can see through these other examples, Steina's work took on many forms: installation, mechanical sculpture, performance, video, etc. The Vasulkas worked with a multitude of tools such as multi-keys, scan processors, colorizers, frame buffers, and so on. But of course, in this period of time, artists needed to rely on connections, usually to broadcasting stations and commercial enterprises who own these cumbersome and quite expensive pieces of equipment. While Steina and Woody were able to procure some of their own equipment, they started to build community in their new home of Buffalo, New York, and decided in the mid-70s that they wanted to explore building a new synthesizer that would allow them to move into manipulation of signals in digital space. Originally a collaboration with Don MacArthur, they eventually teamed up with computer science engineer Jeff Shire to build the digital image articulator. Their goal was to create the first video synthesizer using digital signal processing, converting analog signals into digital binary, and using programming interfaces to interpret and manipulate this converted signal. They began by using static pattern sequences, as seen in the image on the right, first gradated stripes and step patterns, and later more complex geometric patterns. They also used simple commands that worked with the arithmetic logic unit of the PDP-11 computer with the LSI-11 processor board to combine the patterns in a multitude of ways, discovering how logic and arithmetical equations could offer discrete control over individual pixels. Originally built on a 4-bit system, this offered up to 16 levels of densities that they could control in the image, but eventually expanded to an 8-bit system. This tool allowed them to eventually use their visual vocabularies, keying, buffering, tiling, in live feeds, effects which notably were adopted in professional sports broadcasts just a few months later. This period of time also demonstrated an archival aptitude in their practice, in that they would record the development process in videos and also in many schematics and sketches. They wanted this knowledge to be shared and for others to benefit from their discoveries, so as to make the tools more democratic and open. This idea would only continue to expand in their work. Always ones to stay on top of, if not in front of the newest developments, Steina and Woody's work saw further expansion with the introduction of the MIDI protocol, or a musical instrument digital interface. This new innovation was also buoyed by the Sensor Lab MIDI controller box, which would allow for manipulation of signals from MIDI instruments through computer programming. This was an exciting development for Steina, as she could further explore the potential of real-time systems. Of course, the learning curve for this was extremely steep, and very few tools existed for allowing users to program these sorts of responses through MIDI. Interactor was one of the first tools that they played with, designed by Morten Subotnik and Mark Cornelio, though it would only serve as an inspiration for tools they would later build themselves. It was built for Macintosh with a graphical user interface that could interpret MIDI messages and allow for responses to be programmed within a linear scene-based structure. For Woody, the ultimate goal was to use MIDI messages to be interpreted in object-oriented languages and offer discrete control over mechanical objects that he had found in the Los Alamos Lab's salvage areas, such as the Celestial Navigator, a slip-ring assembly rotate pan tilt camera, which would eventually be used in his interactive installation series, The Brotherhood. For Steina, she was interested in using MIDI to be used for real-time control of audiovisual clips and sequences, which could be manipulated by MIDI instruments, such as the Zeta violin. Scripts were eventually written in C that could control laserdisc players, lighting controllers, servo motors, solenoid valve controllers, and many other types of hardware. In refining the use of the MIDI and software tools for real-time manipulation of signals, Steina returned to violin power and reimagined it as a performance. I'm going to turn the audio on for this part. In this performance from 1996, we see Steina in a projected environment, using source material from past video works, such as the selected tree cuts, one of the earlier works generated through the digital image articulator. As Steina plays her MIDI violin, the pitch and velocity is programmed along with a laserdisc player to allow her to progress the images forwards and backwards with varying speed, and also to allow for distortion, or as Steina would call them, displacements. Displacements was a term, that she coined during their analog phase to describe ways of distorting and interrupting the signal. In working with Russ Gritzo, a former engineer at Los Alamos Labs, she was able to write scripts in a C-like language that allowed for these displacements, first staging the performance in 1992. She would continue to refine these scripts over the years, such as with other engineers like Peter Biles and Mikhail Saup, who also worked in C, but also explored other tools being developed at Stein, the studio for electro-instrumental music in Amsterdam, who also designed the Sensor Lab MIDI controller. One such tool was the graphical user interface tool LISA, or short for live sampling. LISA functioned in a manner somewhat similar to Interactor in its use of a scene-based structure, though it expanded on building pattern sequences for real-time sampling and manipulation of sound waves, not just simple send and receive messages. Another Stein tool, Big Eye, developed by Tom DeMeyer, aimed to receive video information and encode it in MIDI for similar aims of manipulation, buffering, sequencing, and synthesizing. But limitations in its processing power left Steina wanting more. This would change in 1996 when Steina was appointed the artistic co-director of Stein and was paired up with Tom DeMeyer, the developer for Big Eye, to design a new tool for video manipulation, Imagine. It was not like Big Eye in that it was not built using MIDI as the unifying protocol, but was very similar in its use of buffering, sequencing, and discrete control over digital signals, in this case the pixel plane rather than audio signals. Advancements in the PowerPC chip and the advanced RISC machine processing meant that video signals could be manipulated in real time, expanding from 15 frames per second and 120 by 150 resolution to 20 frames per second HD video. Having a multitude of control options was essential to Steina, including the core image displacement effects that had long been part of her vocabulary, soft keying, emulation of scan processing, and newer effects such as slit scanning, which built upon soft keying and can be prominently seen in Steina's Warp. It was important for the tool to have a more intuitive user interface design with immediate real-time processing, not relying on rendering before you could see the results. It utilized a graphical user interface to allow the user to control discrete aspects of the frame and save these in sequences that could be referenced in real time. The temporal manipulation controls allowed for the buffering of images caught real time, captured milliseconds apart, and would generate an image that was a composite of discrete time frames that dynamically cycled through. Like the articulator, the displacements could be mathematically driven, approximating waveform oscillators and other emulations of analog synthesizers through table interfaces. But Imagine went one step further by allowing these manipulations through the pixel mapping. Imagine would not only be used in much of Steina's late 90s videos into the new millennium, but could also be interfaced with tools such as Isadora, which would allow for real-time manipulation of video in a performance setting. Mark Cornelio, developer of Isadora, claims that the development of Imagine directly influenced a lot of thinking around the development of Isadora, with mostly differences in terms of the interface design, and this would later be attributed as some of the early precedents for the design of Mac's MSP. It is worth mentioning that all these tools and related documentation were free and openly available, but this begs the question of what precedents existed within the new media artist community that might have differed from development and distribution models in the commercial sector. While I intend to further probe the inner workings of the Vasulkas tools and their use in specific artworks, I'm also wanting to make a case for the Vasulkas and their archive within the research discipline of media archaeology and the broader open source movement, which is where the next phase of my research will reside. Many of you are probably familiar with this excellent publication, The Emergence of Video Processing Tools, by Kathy High, Sherry Lee Hawking, and Mona Jimenez, for which the Vasulkas analog works are well represented, as well as some of the digital tools mentioned today. Of course, there's a long history of artists creating digital and computer-generated artwork, which, through the early 70s and 80s, was generally aided by access to residency programs at research labs and manufacturing facilities, a la Bell Labs, MIT, or the NYIT Computer Graphics Lab, where artists such as Rebecca Allen designed some of their first programs for computer animation in the early 80s. Many of these facilities employed supercomputers, such as the Cray XMP, which of course were very cost prohibitive for independent artists. Tools such as the Quantel Paintbox emerged, which still came with a high price tag, or the Atari ST, which had an extremely steep learning curve. And then, of course, we have tools that came much later that seemed greatly inspired by this key open source development ethos from the 90s, such as Mac's MSP and Arduinos. How do the Vasulkas, their artwork, and their tools in the development process contribute to our understanding of these histories, or perhaps fill in some gaps? This also further begs the question of the source material for these histories, and the Vasulkas are one example of artists who built a relationship with lots of different institutions who hold different pieces of the puzzle. Over the past decades, many institutions have made efforts to hold the Vasulkas archives, and this is not to say that their efforts have been unsuccessful. However, some of these institutions have since folded or have been absorbed by other organizations, so continuity and transfer of knowledge becomes a problem. Also, given the immense spread of the Vasulkas' work, both finished artworks, something Steina often had conflicted feelings about, or works in progress, there are many collaborations with other artists, and the many materials they amassed as they developed and documented their tools, the archive in reality exists across many holdings, many times in duplication, and some of their material has never left their home and studio in Santa Fe. Of course, as someone who works at a nonprofit legacy institution, you grapple with the reality that permanence is not guaranteed, advocacy is constant, and archives are not necessarily forever. It takes a lot of work for robust, complicated collections to be described and discoverable, and the resources to build and maintain access systems is difficult, let alone the struggles to continue to exist in general. This leads me to wonder about linked data systems and to tell a more complete story of this archive and expose the duplications and absences. My inquiry into these systems is very nascent, and I do not want to undersell the difficulty to adopt such systems in order to be able to participate in some of these linked data projects that I've listed here that are focused on artist work. It was interesting yesterday to hear about OpenRefine and some of the issues with data conformity and specificity, but also very interesting to hear about the talks this morning about some data standards that are emerging. Nonetheless, I think it is only going to become more important for our collections holdings to be able to interface with other institutional repositories, to present more complete and authentic histories, and also to facilitate the preservation process in the face of technological obsolescence. As I said, this research is pending, and I very much welcome your thoughts and experiences on how to make artist-related archival holdings more open and interconnected. So I look forward to hopefully sharing updates soon, but I wanted to leave you with a couple ZKM and Karlsruhe related morsels from the archive. On the left, we see a football match on display at the Karlsruhe train station as Steina zooms in on the various menfolk in attendance, which felt like a nice tie-in with the recent Olympics, as well as an installation at the ZKM of Fabrizio Plessi's Tempo Liquido, which is listed as being on view in 1993. With that, I conclude my talk. Thank you for listening, and I look forward to discussing now, if time permits, or throughout the rest of the conference. Thank you.
We don't have very much time for questions. Maybe one short one, if anyone has something. Yes.
Thank you very much for this very interesting historical thing. When you mentioned open source and then Max MSP in the same sentence, I was surprised I did not see pure data in there at all.
Yeah, I suppose I mean more in not saying that that tool is open source, but that some of these earlier open source tools.
I know, but that you have not mentioned pure data at all. It was just, I was surprised.
Yeah, well, certainly something I can look into for my next phase of research, but.
Okay.
Yeah.
Thank you.